All right, we're going to look at polynomial and rational inequalities. So for number 1, it wants to know, looking at that function, at what two values of x does the outputs change sign? So if you're looking at it, we are positive all in here up till that point. Then we go negative. Then we jump back up. Once we cross, not really cross, but kind of jump over that vertical asymptote. And so then we're positive again. So the two values that we're talking about are going to be right here when x is equal to 2, which is the 0, that's the special feature. And then also when x is equal to 3, which is the vertical asymptote. All right, so it says to put these two critical numbers on the number line. And so if I put those on the number line, that's going to be a 2 and a 3. And so we know that we're equal to 0 at the 2, and at 3 it's our vertical asymptote, so that's where we're undefined. And then what we can see up in the picture, because it wants us to determine the sign of f of x in each interval, well, we are positive when we are less than 2, and then we go negative between 2 and 3, and then we go positive again from 3 to infinity. So that's just a number line kind of to get us ready to show those intervals, which we had talked about in class. So to answer the questions, when is f of x less than 0? We know that that's happening between 2 and 3, and we're not going to include either of those endpoints. We're less than or equal to 0. Again, it's between 2 and 3, but this time because we can equal 0, we'll include the 2 because the 2 is a 0, never including the 3 because that's a vertical asymptote. Now, we're greater than 0 for two different pieces. So the first piece there is going to be from negative infinity to the 2, and the other one is going to be from 3 to infinity. And we'll put parentheses on both of those and a little u between them. Now, greater than or equal to 0, again, we're going to include the 2, but we will not include the 3 because, again, we're undefined there. All right, for number 2. Now, we don't have a picture for this, but using some of the stuff that we have been noticing, if it's a polynomial, which is what we have here, the times where it changes signs is based off of the zeros. We don't have to worry about a vertical asymptote because we don't have a fraction. So our zeros are going to be 0 because 5x is equal to 0 and x is 0, negative 2 for that factor, and then a positive 4 for that guy. And if you're not sure why, set it equal to 0, and if you add the x over, you're going to get 4 equals x. We have that positive 4. So we put those critical numbers on our number line. Remember to go from littlest to biggest. So littlest is negative 2, then we have 0, then we have 4. Now, since I don't have a graph, I mean, you could graph this. We know enough about graphing, multiplicities, and things to be able to graph it, a sketch of it, but we can also plug in values to see. So if we want to test something to the left of negative 2, something like negative 3, what that means is we go to that function right there, that polynomial, and we plug in a negative 3 to see what happens. So 5 times negative 3 times negative 3 plus 2 squared times 4 minus negative 3. So this is going to be negative 1, and then we're going to square that. So let's see, we'll kind of do this together. So 5 times negative 3, that's negative 15, times negative 1 squared will be a 1. And then lastly over here, 4 plus 3, that's 7. So we don't actually need the total product. We just need to know if it's positive or negative. You can see it's going to come out to be negative. All right, let's try that again. So I'm going to test something between negative 2 and 0. So how about we test negative 1? So again, we put negative 1 in for everything. And you can kind of just start thinking, okay, if I go again, let's go up to this guy. If I plug in a negative 1, let's think about what's going to happen. The first little chunk here will become a negative. Negative 1 plugged in there is going to become a positive, and it's squared, so it's still positive. And then negative 1 in here, that's minus a negative, so we're still going to be positive. So our output is going to end up being a negative number because negative times positive is negative. So then the next thing we have is to test something between 0 and 4. So to test that, let's try 1. So again, we go up and we're just kind of thinking about signs. That's all we really care about. Are we going to get a negative or a positive result? So if I plug a 1 in, we're going to get a positive. 5 times 1 is a positive. 1 plus 2, that's a positive. 4 minus 1, that's also a positive. Everything's positive. We're going to get positive in that little interval. Lastly, test something bigger than 4. So if we tested like 5, again, going back to the top function, if I plug in a 5, I'm going to end up 5 times 5, that's something positive. 5 plus 2, that's positive. 4 minus 5, now that's going to be negative. So a positive times a negative ends up being negative. All right, and I'm going to kind of sketch over this too to like imagine if we were on a coordinate plane here. We know that the total degree was going to be a power of, let's see, we have a x to the 1. We have x plus 2, that's squared, and then 4 minus x is to the first. So we know we're going to have an x to the 4th. So we're 4th degree. Coefficient-wise, we have a 5 going on. The x in the x plus 2 only has like a 1, so it don't really matter. And then we have a negative 1 in that last term. So really that's going to be 5 times 1 times negative 1, so we're going to get negative 5. And so that is odd, or not odd, a negative lead coefficient. And if we're degree 4, then we know our end behavior. So if I kind of sketch that onto this little number line, and again, thinking about multiplicities and things like that, the x equals 0, that was a multiplicity of 1. Negative 2 was a multiplicity of 2, and 4 was a multiplicity of 1. So remember, we go through if it's an odd multiplicity, we bounce if it's even, and then we go through again if it's going to be odd. So at negative 2, we would bounce. 0, we would go through, and then we'd come back down and go through 4. So that's kind of what a super rough sketch would be. And that matches up with the signs that we got. We said negative, negative, because we're below the x-axis there. Then we switched over to positive because we're above the x-axis, and then we went negative again. Okay. And again, all of these were critical kind of values here because they were the zeros. So to answer the question on what values are these intervals true, if we want to talk about, well, less than 0, that's going to be negative infinity to negative 2. Don't include negative 2 because that's the equal to 0. And then from negative 2 to 0, and then 4 to infinity. Now, if we're going to equal 0, we're actually going to be able to do all those from negative infinity to 0. We don't have to split it at that negative 2 because it's included there. So we're going to have negative infinity all the way to 0, including the 0, and then 4 to infinity again, including that 4. Now we're greater than 0 only on the little interval between 0 and 4, and we're greater than or equal to it, 0 to 4, including those endpoints. And then also don't forget that it was with that negative 2 number also. We are equal to 0. Okay, and I guess I was a little ahead of myself because I wanted to show you that sketch. But if we put it down in here, continuing on our rough sketch, we know it says to plot the zeros. We already know them. They were at 0, negative 2, positive 4. And our end behavior we know was already both pointing downward. And our y-intercept, well, we get that by plugging a 0 in. So we're going to get 0 times all that stuff, which really puts us at 0, 0. That is our y-intercept. And just like we said before, negative 2, we bounce because it was of even multiplicity. We're going to have to come back up through that x-intercept and y-intercept, then come back down and go through the 4. And so you can see it matches up that we are negative, negative, positive, negative for those little intervals. All right, we have a few rational functions going on. So for number 3, again, it wants us to find the critical numbers. Those happen where we have zeros or x-intercepts, and also where we are undefined or where we have our vertical asymptotes. So our zeros here are going to happen when our numerator is equal to 0. So that's when w squared plus 2w minus 3 equals 0. So we're going to factor that. That would end up being a positive 3 and a negative 1. So the zeros are at negative 3 and positive 1. And then our vertical asymptotes are when the denominator equals 0. So that's going to be W, and we'll put -2 and +1 this time because we need to multiply to -2 but add to a -1. So our vertical asymptotes are at W equals 2, W equals -1. So we're going to put all of these values, or have to consider all these values when we're looking at our inequality. So I'm going to plot them down below on the number line. Again, little numbers to bigger numbers. And I'm going to write a note because these are really important that they weren't all zeros this time. 2 was a vertical asymptote, so we are undefined here. So we're never ever going to touch there. And then we have -1 is also undefined, while the other guys we know are just zeros. So keep that in mind. And so we could do that whole testing values, so test some numbers. And it might actually be nice, I'm looking back at this, to see this in the factored form when we do our testing. So the numerator was W plus 3, W minus 1, and the denominator was W minus 2, W plus 1. And so if I want to check something, I'm going to check like -4. If I go back to the factored form, if I put -4 in, a -4 plus 3 is a negative, -4 minus 1 is a negative. On the bottom, we're going to get negative, negative. So a negative times a negative on the top is actually positive. On the bottom, negative times negative is also positive. So positive divided by positive gets us positive stuff in there. All right, let's try that again. So let's test something between -3 and -1, so like -2. So again, I go up to my factored form, and I'm thinking about -2. So -2 plus 3 is a positive. -2 minus 1 is negative. -2 minus 2 is negative. -2 plus 1 is negative. So on the top, I'm going to get a negative because positive times negative. On the bottom, I'm going to get a positive because negative times negative. When you divide those, you would get a negative. So we have negative there. And we're going to test something between -1 and 1. So I would test 0. Try and go for like easier numbers. You can also do any kind of fraction if you really wanted to. So if I'm going to test 0, 0 plus 3 is positive, 0 minus 1 is negative, 0 minus 2 is negative, and then positive. So on the top we'll get negative, bottom will get negative, so negative divided by negative is positive. Now between 1 and 2, I guess that one we're going to have to test a little fraction. So if we want to test 1.5, let's see what happens. So testing 1.5, that's going to be a positive here. 1.5 minus 1 is still positive. 1.5 minus 2 is negative, and then positive. So we'll get a positive over negative, which is negative. And then lastly, if you want to test a number like, let's say 3, we're going to have, let's go back up here. Testing 3, we're going to have a positive, 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 positive. Everything's positive, so we get positive. So, I mean, without looking at the graph, we're just interpreting what the values would be in those different intervals. So, to answer the question, less than 0, so where are we negative? Well, that's between -3 and -1, and also between 1 and 2. We don't want to equal 0, so I'm not going to include any of those values. Then we want less than or equal to 0. So it's going to be the same intervals, but when you think about what numbers we're including. At -3, we're 0, so we do want to be that guy. At -1, we're undefined, so we don't want to include that. At 1, we're 0, so we do want to include that. And then 2, we're undefined, so we don't want to include that. Greater than 0, that's going to be -infinity to -3. Again, we don't want to include the zeros, so I'll put parentheses. And then from -1 to 1, and then we also have from 2 to infinity. So all those guys, you can put a little u between them. Greater than or equal to 0. So now we're going to have those same intervals, but make sure that you include the zeros, which are again at -3 and 1, and that's it. All right. Okay, so now we can look at the sketch to see kind of what's going on, and then again, this is like a good review of what we've been doing the past few weeks. So the vertical asymptotes, I'm going to plot those in here, 2 and -1. Now notice these are the same degree, so if I want to find the horizontal asymptote, it's just the lead coefficients, so that's going to be at y equals 1. My zeros, we're at -3 and 1. Okay, so that's the things that I do know for sure. Now I do need to check if I cross that horizontal asymptote. And so if I cross it, that means that the entire fraction w squared plus 2w minus 3 over w squared minus w minus 2, we want to see if it's ever equal to that 1 that we found for that horizontal. So if I clear the fraction, multiply by w squared minus w minus 2, w squared minus w minus 2, we're going to get w squared plus 2w minus 3, because those are gone, is equal to, it'll be w squared minus w minus 2. Now if we try and get our w's all on one side, the w squareds will cancel. So I'm going to move this little w over. We're going to get 3w minus 3 equals negative 2. Add the 3 over. We get 3w is equal to 1. Divide by 3. We get w equals 1/3. So what that means is we will get this output of 1 when our input is 1/3. So the point 1/3 1 is on our graph. So 1/3 1, so like right there on the asymptote. Now we don't have any other x-intercepts, so that it can't like come down here. We got to connect those guys, and that's going to follow the asymptote. So we're going to have to go through. It'll look more like a cubic type thing. All right, and then the guy on the left, he's got to touch that x-intercept. Now we have no other x-intercept, so that leaves the other piece up here. And so again, following our kind of critical numbers, which were at -3, -1, 1, and 2, you can see that we are positive here, then we go negative, then we go back to positive, then we go back to negative in that little interval, and then we are positive again, kind of alternating, which we saw in our number line. All right, last one, number 4 here, start to finish, all on your own. So we want to have equal to 0. Everything needs to be compared to 0. So I'm going to have 3 minus x over x plus 2. I'm going to subtract 4, greater than or equal to 0. In order to combine those, we need to have a common denominator. So I'm going to multiply by x plus 2, so that way it matches. So 3 minus x over x plus 2. And then if I take the minus 4 and distribute, that's going to be minus 4x minus 8 all over x plus 2. And simplifying that, what we're really going to have, I'll write my x's first, is negative 5x, and 3 minus 8 is negative 5 over x plus 2. So that's really the rational function that we're going to be talking about. So the big things we need are the zeros and our vertical asymptotes. The 0 happens when the numerator is equal to 0. So if I solve that, just a nice little linear equation, divide by -5, we get this happens at -1. So that's our 0. The vertical asymptote, that is when our denominator equals 0. So that's going to happen when x is -2. And so if I kind of just think about the number line, not the whole entire graph, but our little number line, we're going to have a -2 and a -1 on there. Again, -2, we're undefined. -1, we are 0. And we could just kind of do our testing. So I could test -3, that's in that little interval. I could test -1.5, then over here I could test 0. And what I wanted to test into is just this new rational function that I wrote up. That way I'm comparing to that 0. So if I plug in -3, let's think about that. If x equals -3, that's going to be -5 times -3, which will be positive 15 minus 5, which is positive. And then on the bottom, I'll get negative. So that's actually going to give me a negative result because positive divided by negative is negative. If x was equal, and I'll just write this again, if x equals that -1.5, again, still plugging in to that -5x minus 5x plus 2, and that's going to turn into a positive, let's see, what will that be? 7.5? Yeah, 7.5 minus 5, so it's still going to be positive on the top. And then on the bottom, a -1.5 plus 2 is positive. So positive over positive gets us to have a positive. And then testing 0, that's kind of the nicest one to plug in. If I want to test 0, on the top, I'll get a -5, so that's negative. Over on the bottom, I'll get positive. So again, that's a negative result. So I'll put that in that interval. So what we were actually concerned with was trying to see when we are greater than or equal to 0, which is only happening, here, I'll highlight that, it's only happening in here. That's when we're positive. So the answer to our question, final answer, is going to be between -2, -2 and -1. And we want greater than or equal to 0. We will not include -2, but -1 is a 0, so we will include that. So that would be my final answer.